Good morning, everybody. Today I will be dealing with the remaining part of my lecture previous day on neuron. Myelination. Peripheral nerve fibers of the myelinated variety are covered by myelin sheath derived from the Schwann cells, whereas myelinated neurons in the CNS derive their myelin sheath from oligodendrocytes. The peripheral nerve fibers acquire the myelin as the Schwann cells revolves round and round the axon mass many times, giving rise to a multi-layered sheath. In contrast, in unmyelinated nerve, the Schwann cell simply encircles the axon in a single layer and does not go round and round as in a myelinated nerve. In myelinated nerves, nodes of Ranvier are the myelin-free regions in between adjacent Schwann cells. Ions and electric current can freely pass through these sites, unlike the myelinated portions which are not non-conducting due to the presence of the myelin. In the insulating, that is non-conducting property of myelin is probably due to its high cholesterol content. The conduction velocity of a myelinated nerve is very high for the following reasons. The electrotonic cable-like conduction of a nerve impulse, as for example, which occurs between the nodes of Ranvier in a myelinated nerve, is much faster than conduction which progresses by a regenerative process as an AP, that is action potential. Hence, the conduction along a myelinated nerve requiring fewer action potentials which occur only at the nodes of the Ranvier very fast. On the contrary, an unmyelinated nerve has plenty of ion channels throughout its length, so successive action potentials form at contiguous sites much closer to each other. Number of action potentials formed during propagation is much more in the unmyelinated nerve. Hence, the conduction of action potential is much slower. The thick myelin sheath reduces the capacitance of action membrane. This is because of greater separation of charges across the thick myelin sheath. So there is less affinity between the charges. This also predisposes to rapid depolarization. As the myelin covered segments are insulated, electrical charges cannot leak through them. So an increased number of charges arrive rapidly at the next node of Ranvier with a decreased loss in quantity and produces an action potential relatively early. As the action potential forms only at the nodes of Ranvier, it appears to jump from one node of Ranvier to the next, and this is known as saltatory conduction. Myelinated actions have the following special features. The nodes of Ranvier do not contain the potassium channels. Potassium channels are essential for the prolonged after hyperpolarization, which is a part of relative refractory period. Consequent shortening of relative refractory period allows these actions to fire at a higher frequency. As ionic currents flow only across the nodes of Ranvier, the total amount of ion movement across the nerve membrane is relatively small. This requires much reduced activity of sodium-potassium ATPase to restore the ionic balance after an action potential. So energy requirements is much less. Myelination starts in utero at about the 4th month of intrauterine life. At birth, the pyramidal tract is unmyelinated. Myelination of pyramidal tract is not complete until the completion of the 2nd year after birth. Thank you. I come to the end of my today's lesson on the neurons.